So what is a simple harmonic motion? This is an example of a simple harmonic motion in action. I started the spring position at 0.1 meter. Then as you see, the object starts to move to the upward to the left towards 0.6 meter and then move to the right towards the starting point again. As you see, the objects move around 2 points and produce a velocity and acceleration graph that seems to be a sine graph.
Okay. Hi guys, today we'll be talking about simple harmonic motion in MAS terms. So as you can see here, simple harmonic motion is when your acceleration is equivalent to negative k square x. This is the identity that represents simple harmonic motions. Now we need to prove that this form can get us the v and the x respectively of a simple harmonic motion. So as you can see here, a, your x dot dot is simply just a, which is also dv over dt, which is equivalent to negative k square x. However, since there's no t here, we can rewrite this whole thing into dv dx multiplied by dx dt equals to negative k square x. This is with the usage of chain rule, it helps us to do so. And you can see that dx dt is simply just velocity, because if you differentiate x over time, you get velocity. So you get v dv over dx equals to negative k square x. By throwing the dx over this side, you can basically integrate this. If you can integrate v dv equivalents to negative integrate of k square x dx. If you integrate that using your integration, whatever, you will get v squared over 2 equals to negative k squared x squared over 2 plus c. And if you have noticed from our friend's slides that when the object starts to stop, when v equals to 0, you simply will get the amplitude, which is how far they travel. So you can just sub in v equals to 0 into the v, and you can sub in x equals to a, and hence you get c equals to k squared a squared over 2. Thus, by rewriting the whole equation, you will simply just get v squared equals to k squared bracket a squared minus x squared. So this will be the general equation of the velocity of a simple harmonic motion. But since we're only taking the positive side here, you can also rewrite into v equals to square root of a squared minus x squared. And again, since we already mentioned v is simply just dx over dt, hence we can just rewrote in this form where dx over dt is simply just equivalent to k square root of a squared minus x squared. And then we will rewrote it because we want to integrate both sides into this form. Integrate of 1 over square root of a squared minus x squared dx equivalent to integrate of k dt. And by using let u substitution, you can actually do the integration. So if I let x be a sine u, where you dx du is simply just a cos u, hence you get dx is equivalent to a cos u du. Let me just rub all this so that I got more space. Hence you can just sub that in. You get dx is simply a cos u du, and you will get square root of a square minus a sine u square is equivalent to this thing. And that can be rewrote in terms of a cos u still remain, and then the a square can be obtained outside, meaning you can factorize outside, and you will get 1 minus sine square u inside. Du is equivalent to the integrate of k dt. And if you have noticed, 1 minus sine square u is just simply cos square u. So hence you get a square cos square u inside the square root, du equals to integrate k dt. And by doing so, you will simply just get a cos u divided by a cos u du. You simply get just 1 du equals to integrate k dt. And by doing so, you will get u equals to kt plus alpha. The alpha is simply just c actually in our indefinite integral, but in this case, because this simple harmonic motion is known as alpha, and we just sub back into x is equal to a sine u, hence you get a sine kt plus alpha This will give you the general equation of simple harmonic motion for x. And then we will see the summary later on. So as a summary, we can see that if it's a simple harmonic motion, your acceleration for simple harmonic motion is simply just be negative k square x. And for general equation, as we derived just now, x is simply just a sine kt plus alpha. So when you start from O, means when t equals 0, you start from x equals 0, you get x is equivalent to a sine kt. This is done by deriving it from the general equation. So let's just say I have it here. When my t equals to 0, I will have it x equals 0 as well. You get 0 equals to a sine alpha. So your alpha would be 0. Hence you will get x is equal to a sine kt. However, let's say I start from somewhere else. When t equals 0, I start with x equals to something else. I would need to derive that to find my alpha, because alpha is a constant that I did not obtain. So this will be my general equation. If I sub x to be a number, let's say a, x equals to a and then a sine alpha. Hence your alpha is simply just pi over 2. And hence you will get x is equivalent to a sine kt plus pi over 2. And if you have known your trigo well, that would bring you to a cos kt, which is what we see here. The time for, just in case you can't see, so this will be alpha, pi over 2. The time that was traveled in a cycle, means if you have known the graph to be something like this, and this is like one cycle, would be simply explained by 2 pi over k. And as we derived just now, the v and the v square would be what you would use in a simple harmonic motion. And to find the maximum velocity of the v, you will just simply be a magnitude of ka. And that will be all for simple harmonic motion. This may not be clear, but any inquiry you can always refer to Miss Lai. Thank you.